Hello, everyone, and welcome to today's session. I'm excited to introduce our presentation on Python interview questions and answers for freshers. This is part 1, focusing on Python syntax and semantics. We'll be exploring some fundamental concepts that are essential for any Python interview. Over the next few slides, I'll cover key topics that will help you prepare effectively. So let's get started and dive into the world of Python. So what is Python exactly? Well, Python is a high-level, interpreted, and general-purpose programming language. That means it's designed to be easy to read and write, while also being versatile enough to handle a wide range of tasks. One of its key features is its emphasis on readability and clear syntax. For example, instead of using curly braces or keywords to define code blocks, Python uses indentation. This makes the code more visually organized and easier to understand. Another important aspect is that Python supports dynamic typing. This means you don't have to specify the type of a variable when you create it. The interpreter figures it out at runtime. Plus, Python handles memory management automatically through garbage collection, so you don't need to worry about allocating or freeing memory yourself. It also supports multiple programming paradigms, whether procedural, object-oriented, or functional, giving you flexibility in how you approach your programming tasks. Because Python is high-level and interpreted, it abstracts away many low-level details like memory management. Instead, it runs your code through an interpreter, which makes development quicker and more straightforward. Its indentation-based structure promotes readable, clean code. Imagine an if statement, where the code inside it is indented to clearly show what belongs to the condition. Regarding types, variables in Python don't need explicit declarations. The interpreter infers their types at runtime, which makes coding faster and less verbose. However, Python still enforces strong typing, so it won't automatically convert incompatible types, helping you avoid unintended errors. Finally, Python's support for multiple paradigms means you can write structured procedural code, use object-oriented techniques with classes and inheritance, or leverage functional programming features like lambda functions and higher-order functions. This multifaceted approach makes Python a powerful and flexible language, perfectly aligned with our goal of understanding versatile programming tools. Now, let's talk about how to add comments in Python, which are essential for making your code understandable. First, we have single-line comments, which are indicated by the hash symbol, hash. Anything you write after the hash on the same line will be ignored by the interpreter, so you can use it to explain what your code is doing or leave notes for yourself. For example, you might write hash this is a single-line comment in Python, and then your code follows like print, hello, world. Comments can also appear after your code on the same line, as in print, hello, hash this prints a greeting. Next, let's look at multi-line comments. These are useful when you want to add longer explanations or documentation within your code. Python uses triple quotes, either, or, to enclose multi-line comments. Anything inside these triple quotes can span multiple lines and will be ignored if it's not assigned to a variable. These are often used for docstrings, which are special comments placed right after function or class definitions to describe what they do. For example, you might write, "This is a multi-line comment or docstring. It can span several lines." It's important to note that while triple quotes can act as multi-line comments, technically they create a string object. If you don't assign them to a variable or use them as a docstring, they're just ignored by Python, but they're slightly different from using hash comments. When placed immediately after a function or class, these docstrings can be accessed via the built-in help function, making your code more informative and easier to understand. So, in summary, single-line comments are quick notes using, and for longer explanations, you can use triple-quoted strings, especially for documentation purposes. Both are valuable tools for writing clear, maintainable Python code. So, is Python case-sensitive? Yes, it definitely is. This means that uppercase and lowercase letters are treated as completely different, which is a crucial point to remember when you're nomming your variables, functions, or classes. For example, if you create a variable called myVar and then try to access myVar or myVar, Python will see them as 3 separate identifiers. This rule applies across the board, whether you're working with variable names, function names, or class names. For instance, if you write print with a capital P, Python doesn't see it as the same as the built-in print. Function with a lowercase p, if you haven't defined print yourself, you'll get a name error, indicating that Python doesn't recognize that identifier. Understanding this case sensitivity is essential because it can prevent a lot of bugs in your code. It emphasizes the importance of being consistent with your nomming conventions. And of course, it ties into the overall theme of writing clear, readable, and error-free code in Python. When it comes to nomming variables in Python, there are some important rules to keep in mind. First, variable names or identifiers must start with a letter, either uppercase or lowercase or an underscore. After that, they can contain letters, digits, or underscores. But remember, names cannot start with a digit. For example, value, my var1, and data2 are all valid names. However, one value or var name are not, because they violate these rules. Also, keep in mind that variable names are case-sensitive, so my var and my var are considered different. Now, there are a few other important points. For instance, a variable name can't be the same as a reserved keyword in Python, like if, for, or class. You can easily see all the keywords by importing the keyword module and printing keyword, kwlist. Moving on, there's a nomming convention called snake case, which is used for variable and function names. By convention, these are all lowercase words separated by underscores, like my variable. Class names, on the other hand, typically follow Pascal case, starting with a capital letter. Finally, I want to emphasize the importance of choosing meaningful names. Descriptive names make your code more readable and easier to understand, especially when you or others revisit it later. So, using clear, expressive names is always a good practice. So let's talk about what dynamic typing means in Python. Essentially, Python uses dynamic typing, which means that variables don't have a fixed type. Instead, the type is associated with the object they refer to at any given moment. This allows us to reassign variables to different types during runtime. For example, if I set x to 10, x initially refers to an integer. But then, if I do x equals hello, now x refers to a string. This flexibility makes Python really powerful and quick to write because we don't have to declare types explicitly. The type is determined automatically based on the object. But it's important to remember that Python is also strongly typed. That means if we try to perform incompatible operations, like adding a number and a string, Python won't try to guess or convert automatically. Instead, it will raise a type error, alerting us to the mismatch. So, while dynamic typing adds a lot of flexibility, Python still enforces certain type rules to keep things predictable. This balance is a key part of Python's design, making it both easy to use and robust. So, what exactly is indentation in Python, and why does it matter? Well, indentation, which is simply the white space at the beginning of a line, is actually mandatory in Python. Unlike many other programming languages that use braces or keywords to define code blocks, Python relies on indentation to do that job. For example, in an if statement or a loop, all the lines that are indented underneath are considered part of that block. To illustrate, if x is greater than 0 and we want to print positive, we indent that print statement under the if condition. The same goes for else. The indented line after else is part of that block too. Now, if you mess up the indentation, say you forget to indent or do it inconsistently, Python will throw an error, specifically an indentation error or a syntax error. This rule actually helps keep Python code readable and clean, but it also means you need to be very careful to use consistent indentation, typically 4 spaces per level, following PEP 8 guidelines. So remember, indentation isn't just about style. It's a core part of Python's syntax that determines how your code is structured and understood by the interpreter. So how do you print output in Python? Well, in Python 3, the main way is using the built-in print function. For example, if I write print, hello world, it will display hello world followed by a new line. This is the most straightforward method to show output on the screen. The print function can also accept multiple arguments, and by default it separates them with spaces. For instance, if I write print, hello world, it will output hello world. You can customize the output further using optional parameters like end and sep. For example, if I want to add an exclamation mark at the end, I can write print hello world end equals. This will output hello world on the same line instead of starting a new line. It's important to note that in Python 2, print could be used either as a statement, like print hello, or as a function in newer versions like Python 2.6 and above. But for modern Python, especially Python 3x, always remember to use print as a function. This helps keep your code consistent and compatible with the latest standards. Understanding how to print output effectively is fundamental because it ties into how we display information and interact with users in our programs. Now let's talk about comments and docstrings in Python. Comments, as you know, start with a hash symbol, hash, and they continue until the end of the line. They're meant for developers to add explanations or notes within the code, and importantly, Python completely ignores them during execution. So use comments to clarify your code and make it easier for others, or even yourself, to understand what's happening. Next, we have docstrings. These are a bit different. A docstring is a special kind of string literal written inside triple quotes, and it appears immediately after a function or class definition. Think of it as a built-in documentation for that specific function or class. For example, if you define a function called add, you can include a docstring right after the def line that explains what the function does, like returning the sum of two numbers. And here's the key point. These docstrings aren't ignored by Python. Instead, they're accessible through the help function or via the doc attribute. So they serve as an essential documentation tool, helping you and others understand what your code is supposed to do, right within the code itself. This way, your code becomes more readable and easier to maintain over time. So, what does it really mean that Python is interpreted and dynamically typed? Let's start with interpreted. That means Python code is executed by an interpreter at runtime, rather than being precompiled into machine code before running. This allows us to run Python code directly, which makes testing and editing much easier because we don't need a separate compile step every time. However, it also means that errors like syntax mistakes or type errors can show up while the program is running, not beforehand. Now, moving on to dynamically typed. This means variables in Python don't have fixed types. You can assign a variable to a number, then reassign it to a string or any other type later on. The type checking happens when the code runs, not when you write it. This offers a lot of flexibility and speeds up development because you don't have to declare types explicitly. But it also means that some errors, like trying to add a number to a string, might only happen when that specific line executes. So overall, these features make Python very flexible and user-friendly, especially during development, but they also require us to be mindful of potential runtime errors. This connects to our theme of understanding Python's ease of use and versatility in programming.